Hi everybody, I hope that you remembered some of the basics about slope that you've learned last year and the year before. So now what I want you to do is pause the video and figure out this problem. Okay, so hopefully you did this. So the two pieces of information we have here is that in 1 hour you went 32 miles, and then after 3 hours you went 102 miles. So those are the two big pieces. So 1 hour was 32 miles. Use a different color. And then 3 hours was 102 miles. So what is the average rate of change between those two times? So the first thing we might want to do is figure out how many hours. So that went up by 2 hours. And over here, this goes up by 70 miles. So you have 70 miles per 2 hours. And that simplifies down to 75 divided by 2 hours, right? If we take that, that's 35 miles per hour. And with rates like that, we always use one single piece, right? We never say 70 miles per 2 hours. You would always break it down to say 35 miles per hour. So that really helps out with that. Let's see. Okay. So in slope is basically the same thing as rate of change, except we talk about it when it's really just numbers, when you don't really have a label to it. So it's always called rise over run. It's your change in y per your change in x. So just like that last problem, the y variable would have been miles and the x variable would have been hours. So your change in y, your change in the miles per the change in x, the change per the hours. Okay? And it's always written as a fraction and an improper fraction. Or a whole number if it works out to be a perfect whole number, that's fine. Improper fraction or a whole number if there's no pieces to it. That's fine. Rise over run, change in y over change per x. Now there is a formula for this. There's two ways to figure this out. One of them is to do this, y2 minus y1 over x2 minus x1. And it equals m. M is just the letter that slope is. Okay, so that's one way to figure it out. Now, all that really means, let's use it. Let's do this formula. Is you have an x and a y, and another x and another y. Well, this is the first set of y's, x and y, and this is the second set of x and y. That's it. So then you could plug it in. y2 minus y1 over x2, right? We're just using it, minus x1. 3 minus negative 4 is 7. Negative 3 minus 2, O3, O2, U, O5. And that's your answer, negative 7/5. That's it. It's an improper fraction. It's simplified, but we're not going to split it up. Okay, now this one, I'm going to do a different way. I'm going to put these right on top of each other. The y's go up by 2. The x's, negative 5 to 1, goes up by 6. Simplify that fraction, 1/3. Done. If you used the formula, you would have gotten it right? If I did 3 minus 1, y2, y1, x2, x1, over 1 minus negative 5 is 2 over 6 equals, which is 1/3. So you don't really have to use that formula, but it's a good one to know. Here we go. I'm going to do it with the formula. x1, y1, x2, y2. 5 minus 5 over 2 minus 1. 0 over 1 equals 0. That's important. Your answer is actually 0 here because 0 is on the top. Now the next one, x1, y1, x2, y2. 8 minus 2 over negative 3 minus negative 3. becomes 6 over 0. Now 6 over 0, you can't have a 0 in the denominator. That's bad. The world's going to explode. So your answer here is undefined. It's an undefined number because you can't divide by 0. So this one's undefined. I should have put that in 2 different colors. And this one is 0. Okay, 0 on top is 0. This one on bottom is that. Here's another way to remember that. If you have a 0 on the bottom, it kind of looks like a unicycle, right? If you have like a number on the bottom, a 0 on the bottom, it looks like a unicycle. And a unicycle is unusual. You don't usually see unicycles around, so it's undefined. Unicycle is unusual, so it's undefined. But a 0 on top is fine. It's just 0. Okay, slide 3. It's going to be a long video. Okay, now when you're using it from a graph, there's 2 ways to do it. One way is to actually go and start drawing on it. This one's harder to do because you can't really see it. So what we're going to do is plot some points. This point here is 0, -2. This one here, let's find another perfect point. Let's go right here. That looks like a point. 3, -4. Now you see how I went through and I plotted points that totally, truly look like they go through an intersection? Always, always, always find points that go perfectly through, or that are perfectly on grid lines. I call those perfect points. And the reason for that is because if they're not on the line, then you're not using them to find the right equation, right? Okay, so I'm going to use this method. -2 to -4 goes down by 2. 0 to 3 goes up by 3. -2/3. There we go. Let's find 2 perfect points on this one. Now this one doesn't go through perfectly, so we're not going to use that one. I'm going to use this guy right here, which is 5, 5. And then let's use someone over here. Let's use this one, which is -5, -3. Okay. This from 5 to -5 goes down by 10. From 5 to -3, that goes down by 8. -8 over -10 simplifies to +4/5 because a negative divided by a negative. And that's it. Super easy. Okay, rate of change, again, is when you have actual words. When you have a real situation. And when you have actual words, you need a label at the end. Rate of change, when there's actually words, you can have a mixed number. Mixed numbers are okay. Okay, so let's break it up. For this problem, we're going to find 2 perfect points, and I'm going to write it out. 0, 5. Here's another perfect point. There's another one here. We could use, let's just use this one. That's fine. That's 50, 4. Now it's important to write it out because if you notice, the scales aren't the same. So we really do have to write these points down. This goes up down by 1. This goes up by 50. So your answer is -1 over 50. We're going to do this. The Y label, gallons, per the X label, miles. So you're always going to follow this formula. You're going to put your answer, your number, your Y label, the word per, your X label. And that's it. There's not really a science behind it. Where are we now? Slide 5. 2 more slides. Then we're done. Which section is the greatest rate of change? So go ahead and pause the video and figure it out. Take a guess. Okay. I'm going to guess just from looking at it E, but now we need to prove it. So A, this goes from 0, 0 to 280. So that's a change. A has a change of plus 80 plus 2. So that's 40. So A has a rate of change of 40. B, I don't even have to do the math, has a rate of change of 0. Because if you wrote it down, this is 280 and 380. Well, our change in y is 0. Our change in x is 1. So 0 over 1 equals 0. We know that. C, this is 380. That's 4 120. So C has a change of 40. So that's the same as A. D goes from 4 120 to 6 120. Again, that's going to be a change of 0. Oops, sorry, plus 0, plus 2. 0 over 2 equals 0. So D also equals 0. And then let's look at E. E starts at 6 120 and it goes down to 8 0. So this went up by 2. This went down by 120. So that's a change of negative 60. That's definitely the biggest one because 60 is a more dramatic change than 40, even though it's going downhill. Last slide. Okay, so our slope here on both of these, let's pick 2 points. Let's just pick this one, which is negative 3, 5, and this one, which is 3, 5. And let's use our formula because we haven't used that in a while. Remember, the formula was m, and m is always slope, even if you're not using the formula. Okay. 5 minus 5 over 3 minus negative 3. Well, that becomes 0 over 6, which is 0. So a horizontal line, straight across line, horizontal line has a slope of 0. Is always 0. Okay, now this one, let's use this point because it's highlighted. That's what, 4. Oh, sorry, negative 3, 4. Did it in the wrong order. Negative 3, 4. And this one is what, negative 3, 1. Negative 1. Now this time, that went down by 5, but the x's didn't change at all. That looks like a unicycle, so it's undefined. I have to move this. Undefined, right? A straight up and down vertical line is always undefined, okay? You can't walk up and down that line, so it's undefined. That's how you get that. Okay, now you need to go on and do those 2 assessments assignments. I'll see you guys tomorrow.